Welcome back to the PDDL Getting Back to Basics. In the last session, we've coded a hello world example from 0 to hero, but we stayed within what's called a propositional logic. So we only modeled the world using things that are true or false, or otherwise called predicates. Now let's knock it up a notch and let's describe a world where the world itself could be death, and we just need to repeat the greeting multiple times in order for the world to hear us. So I'm starting from where we left off with a single hello world action, and if we just run that model and solve that problem file, we just see the hello world action there in the plan kind of as expected. But what if the challenge is, let's say hello world 3 times? Now it's not going to be sufficient to just work with logical predicates, because even if I repeat it and not now put that into conjunction, repeated the goal 3 times here, 2, 3. Do you think we will see the action 3 times? No, it's still the same. You know, the conjunction of the same predicate 3 times is basically not helping. So we are going to have to do something else. And by doing something else, I mean we are going to have to start counting. And the challenge is to say hello world 3 times. So let's start from the end here and say we are going to be monitoring counter, and the counter shall be equal to 3. This is how you write it, with the prefix notation, where this is again the operator. And what is it saying? It probably doesn't like it because, of course, we don't have counter defined. We'll define it right here. Where would we see that? Well, obviously, if we need to achieve it in the goal, it has to be an effect of some action, and this is the action we have here. We will increase it here, and for increasing, PDDL does have language for that. You increase it in the effect. This is the counter, and we increase it by 1 every time we've said hello. Now, control dot, I can just declare the undeclared function, as well as declaring the requirement, numeric fluence, to signal to the planner that we will be working with numbers. Now, is that going to be good enough? Let's format this slightly. Is this goal needed now? Is this actually useful for anything that we said hello? Well, if we remove it, and if we remove it from here and say not that it's an empty condition like that, and we've defined the counter, obviously, is it going to be just enough to saying hello 3 times? Let's try, and we don't like it. Let's wipe it up. And no, actually, the plan cannot be found. And why is that? Because a well-behaved planner, when you give it a numeric function which is undefined so far, it's like if it had a value not a number, increasing not a number by 1, still gives you not a number, which makes this action useless. We'll never get to 3 unless we say that we start at 1. So equal counter 1, sorry, 0. We start at 0 and we increase by 1 by every application, and we want to get to 3. So is this now going to work? And here we are. So we say hello 3 times. And you can see how the counter is getting incremented with every action here. Now, there obviously could be the case of the planner. Some planners in some situations might decide some actions to be done in parallel or in a sequence. Why is it in a sequence here? It's because all of the instances of these actions, hello world, are touching one common element of the state vector, and the partial ordering mechanism inside the planner basically prevents the three actions to be done in parallel. Well, because this planner isn't smart enough to see that actually it doesn't matter in which order or whether they are all done at the same time. They're all just incrementing the same thing by one. So yeah, they could really be done in parallel. But if we do talk about parallelism, then that actually flourishes completely in the world of temporal planning. So let's actually, for the experiment here, change this model to a durative action. We say this is a durative action, which makes us change the model slightly and makes us declare a duration of, let's say, duration of 1. And the effect needs to be changed slightly by this here at the end of the action, the effect takes place. What are we missing? We are missing a requirement, durative actions. So again, not all planners handle temporal planning. Now, if we did that, we've just modified that action to have a specific duration. And we said that the effect is taking place at the end of it. Do we need to modify anything else? Well, hopefully not. And now you can see that the actions are not happening exactly at the same time, but they are overlapping each other. And if we want to stop these actions from kind of self-overlapping like that, we are going to have to lock them down by some kind of a resource or semaphore. And semaphore will be something that at the start of the action is what do we call the semaphore? We are saying world, saying hello world. So we are busy saying hello world. So let's call it busy. At start, we are not busy. And at end of the action application, we are not busy again. And at start, we are busy. We check that we are, yeah, we declare the predicate. At the beginning, we check that we're not busy yet, and then we toggle that predicate like that in the start and end of the action. And if we rerun, we can see that immediately the model understands that you can't be speaking in 3-time kind of parallel way, and it behaves again. Now, this is something that might not be completely water safe. If there was another action that could be changing the value of busy to, for example, some effect not busy, and it doesn't check that someone else has already kind of set that semaphore, we might actually end up with wrong plans. Let's try to do that. So we'll use another element of temporal planning, and that will be time initial time initial literal. We like that. We'll say that at time 1, we are not busy. And we'll change this to 3, so to kind of have some interplay in time. What is the undeclared requirement time initial literals? So I'll put that there. And just to make sure that I haven't broken anything, if I don't have that predicate there, it now looks the same, just the duration was expanded to 3. And if I put that into the initial state, see what happens. We start saying hello all the way up to the end of the first second. Suddenly the semaphore is changed by something else, which gives the planner the license to start saying hello again right away. And obviously something like that should not be possible, but to the rescue here, the overall condition is something that we could use. So at start, we are not busy. At start, we make it busy, and then we want to protect it busy. So we put overall busy until at the end, we take down that semaphore again. And with that modification, we've just made the model water safe again. In sense of, actually, you can see that we are waiting until time 1 with the start time here until we actually start saying hello, because, well, obviously at time 1, the planner sees that the semaphore is kind of hardwired to go down again. So if we change that to time 5, let's say, what would you expect? It's right about somewhere here. It should say hello at least once, and then it again will need to wait for that semaphore to be available again. So yes, we start saying hello, then we pause until time 5, and then we can say hello twice. So we've done 2 different things here in this one. We started using numeric fluence, and we use durative actions, and on top of that, we used a time initial literal to change the state at particular time points. Hope there was not too many things in one, and see you at the next one.